Alright, let's jump into the summarization for chapter 2 physical objects. So basically this chapter is very long and I'll just summarize the things that you need to differentiate on how you want to use the formula, on how you want to determine the number of m or n. Alright, so basically we have two different parts, two major parts: the slit, interference, the slit or diffraction, and then we have the reflection and refraction in different medium. So in the slit we have yarn double slit experiment, one slit, and diffraction grating. Whereas for reflection and refraction we have thin film, A wedge, and Newton's ring. So for the slit, it is always have central bright. We have the center that is bright. Alright, but just want to state one more thing. For one slit will always comes to the dark part in the formula. Alright, so basically we have already learned about the interference in form 4 chapter 5, the wave. The formula is given below. Lambda equals to AX over D. The lambda is the wavelength, A is the separation between two coherent sources, and S, and this is the distance to the screen. So we have the things inside this chapter is actually the major parts is about interference. So interference, we know that we have two, the constructive and destructive. This is the keywords. These are the keywords that you need to memorize when it comes out in the questions. The keywords for constructive is strongly reflected, appears clearly seen and being observed. Whereas for destructive is non-reflective, missing, unseen, no light is found. Or we can say that we want to reduce the reflection. Alright, so for constructive it is bright or maximum, destructive dark, minima or minimum. So what is this actually? So we have two things which are in phase and anti-phase. In phase is dominated by constructive interference, whereas for anti-phase is dominated by destructive interference. This is just for your understanding. Alright, so what does this mean by dominated by constructive or destructive? So maksudnya bila in phase dia akan berlaku interference constructive. So we look at the bright side. For destructive, we look at the dark side. So the formula for bright for constructive will be normal, whereas for destructive in anti-phase will be normal. It's not going to be complicated. This is what I meant. For in phase is in constructive, so the formula is quite straightforward. Whereas for anti-phase is in destructive, the formula is straightforward. We don't have to add 1 over 2. So let's jump into the yarn double slit. Right, yarn double slit is actually in phase. So when it is in phase, dominated by constructive. When dominated by constructive, we have to look at the bright fringe. Alright, so the formula for the constructive here is actually straightforward. Alright, this is straightforward. Whereas for destructive, we have to add 1 over 2. We have one more formula, which is delta y equals to lambda d over d, that we derive actually from what we learned in form 4. So because this is IP or in phase, so we look at the bright side. Because this is the diffraction, is always start from the center bright. So our first bright will be 1, and it is increasing by the number of the fringe. Whereas for dark, we start from 0 for dark fringe, and it will increasing, or what we can say is m minus 1. Alright, let's have a look at the example. We have yarn double slit experiment, so we know that is in phase. Alright, for 15th fringe, alright, this is the bright and this is the dark. We want to find the number of m. For bright, because this is in phase, so it will always be dominated by constructive interference, so it will be bright. So we just take the number m equals to 50. Whereas for dark, we need to minus 1 because it starts from the 0. So the dark is 49. How about we have 120? It's just the same. For bright, just take. And for the dark, we minus 1. Alright, that's it for yang double slit. This is just the same. Alright, let's jump into one slit. So this is single slit. Alright, so single slit is actually in terms of the number of M or N, we don't really rely on in phase or anti phase because it is not anti or in phase. So basically, for one slit, we will look at the dark side, dark fringe. The formula will be straightforward. So it will always start from the dark. The question will always mention about the minima, the dark fringe, and so on. So basically, for one slit, you just remember the dark is the normal formula, whereas for constructive will be plus 1 over 2 in the N or M. So in terms of N or M, the number that we will use is actually special. We start from 1 for bright fringe and also 1 from the dark fringe, but always start from the dark. Alright, so we have the width of the central bright. The width is actually 2 times Y1 dark. So we always look at the dark side. And the full width is actually 2 times theta 1. Alright, that's all for the single slit. And now we have the diffraction grating. The diffraction grating is actually we are going to measure in on the bright side. So we know that this is starting from the bright side. So we have this formula: D equals to sine theta. D sine theta equals to N lambda. Alright, so first order will be 1. Alright, the distance of nth minima from central maximum, we have to use this. And then the maximum number of order, we just substitute 90 into the theta. Alright, so it's quite straightforward for this diffraction grating because we can just use the number of n and n is just directly use. M equals to 1 when it is first, M equals to 2 when it is the second, and so on. Alright, so this is the formula for diffraction grating. But still, if you don't understand about this, you need to do a lot of exercises. Alright, then we are going to jump into the reflection and refraction. Alright, we have the thin film. Also, A wedges is inside this thing lah. Alright, thin film, we have 2 situations. Let's look at the first situation. It is from 1 to 1.42 to 1.52. So basically, it's going to increase in terms of the optical medium's density. Alright, so actually daripada kecil ke besar and dia pergerakan ray diagram dia, so it is in phase. So when it is in phase, of course dominated by constructive. Dominated by constructive, this is actually we'll look at the bright side. So the bright side, of course, the constructive, the formula is straightforward. Whereas for destructive, we need to add 1 over 2. So because this is in phase, the way we want to choose the number of M start from the bright. So from the bright equals to M equals to 1, whereas for the dark is equals to 0. That's it. For minimum, it's just the same. T here is the thickness of the film. It's just the same. So M equals to 1 when it is bright, and N equals to 0 when it is dark. Alright, let's jump into the second situation. From 1 to 1.42 to 1. So from low to denser medium, and then going back into low medium. So basically, this is antiphase. Antiphase, we know that it is dominated by the constructive. What is the term? Don't remember. Alright, by the destructive. Yes, destructive So it's going to be the dot that we have to look. So the destructive will be straightforward, and M1 is equals to D. As simple as that. Whereas for bright equals to 0. Alright, into the A wages first. So basically A wages have quite different in terms of the number of M, because we don't really have central when it comes to the result of the experiment. So the A wages is from denser. This is the film or another things that have a denser medium, to lower. For instance, we have air, and then to the denser again. So it's actually antiphase. We know that antiphase is destructive. So destructive, we have to look at the dark fringe, because they don't have the central here, because they don't have the central. So the first dot is 0, the second dot is 1, and the number is increasing. Whereas for Newton's ring, we have two situation again. Alright, for in phase dia kena ada ruang udara, whereas for antiphase dia kena sentuh kaca ataupun sentuh permukaan satu lagi. So in phase dominated by constructive, so we will have a look at the bright. So center bright is 0, the first bright is 1, the second bright is 2, and the number is increasing. And then the antiphase is dominated by the destructive. So destructive will have a look at the dark fringe. So the dark fringe will be the center dot is 0, the first dot is 1, the second dot is 2, and vice versa for bright. It's just the same. So for in phase, the bright will be quite straightforward for the equation, whereas for antiphase will be for dark. Alright, that's it for how we want to use the formula inside this chapter. Good luck for midterm.